Hi, this is Dr. Vikas Paul. In this session, we'll discuss about the moving loads and the influence lines. What is an influence line diagram? It is a graph or curve of response function when a unit load crosses the span of a beam from left to right. It is a curve or graph of response function when a unit load crosses the span of beam from left to right. This response function may be reaction at support, shear force, or bending moment, etc. Or we can also define as influence line diagram represents the change in values of reactions, shear force, bending moment due to change in position of loads, especially the vehicle loads on roads, bridges, or moving loads. You can see a figure here, simply supported beam and a unit load on it, 1 kilonewton unit load. So this unit load is moving from A to B. The total span is length L. Unit load is at a distance of x from support A, and obviously from support B it will be L minus x. Considering a unit load on the span AB of length L at a distance of x from A, to draw influence line diagram for reaction, let us find the reactions first. So applying sigma moment A about A equal to 0 minus RB into L plus 1 into x equal to 0. Therefore, RB you will get as x by L. Applying sigma Fy equal to 0, R plus RB equal to 1. Therefore, RA you will get as L minus x by L. Now, influence line diagram for reaction at RA. When the unit load is at A, that is at x equal to 0, RA equal to L minus x by L, that equal to L minus 0 by L, which is equal to RA equal to 1. When the unit load is at B, that is at x equal to L, RA equal to L minus x by L, L minus L by L, that is equal to 0. That means RA equal to 0 at B. So you can draw the influence line diagram for RA now. So at A you will have 1, at B you will have 0. You can see the triangle over there. Then how to draw influence line diagram for RB? When the unit load is at A, that is x equal to 0, RB equal to x by L, 0 by L, therefore RB equal to 0. And when the unit load is at B, that is x equal to L, RB equal to L by L, that is 1, RB equal to 1. Then you can see the influence line diagram. At B you will have 1, at A you will have RB value 0, at B RB value is 1. So when a unit load is moving from A to B, then the influence line diagram for RA will be like this. You can see the figure. At A you will have 1, at B you will have 0, triangle. So the triangle you can see, and below that it is ILD for RB. So RB value is 0 at A, RB value is 1 at B. So it is obvious that when 1 kilonewton is at A, then reaction will be maximum at A only. So RA will be maximum. Therefore RA is 1. When unit load is at A, there will be no reaction at B. Similarly, when unit load is at B, there will be a reaction. RB will be maximum at B, but RB will be 0 at A when unit load is at B. Now let us see how to draw influence line diagram for a shear force at any point C. So ILD for shear force. So here we have two cases. Case 1, when the unit load is in between A and C. You can see the figure there, AB, simply supported beam AB, and some point C. So for first case, when the unit load, so the unit load is moving from A to B. Here we will take two cases. In first case, unit load is in between A and C. Then if we calculate the shear force value at C, we will get minus RB. So shear force at C equal to minus x by L. So case 2, when the unit load is in between C and B, then shear force at C will get as RA, that is L minus x by L. The figure you will get as, you can see there, the figure of ILD for shear force. RB value is negative minus x by L, RA L minus x by L. Then let us draw ILD for bending moment. So you can see that 1 kilonewton is moving from A to B. So at some point C, we need to calculate the bending moment. We need to draw the ILD for bending moment at C. So case 1, when the unit load is between A and C, bending moment at C, RB into L minus A, that is x by L by L minus x by L into L minus A. Then when unit load is at A, that is x equal to 0, bending moment at C value is 0. When the unit load is at C, that is x equal to A, bending moment at C equal to A by L into L minus A, that is L minus A by L into A. So case 2, when the unit load is in between C and B, bending moment at C is RA into A, that is L minus X by L into A. When unit load is at C, that is x equal to 0, bending moment at C is L minus A by L into A. When unit load is at B, x equal to L, bending moment at C equal to 0. Therefore, you can see the figure there. This figure represents the ILD for bending moment at C. At A and B, you will have 0. At C, you will have the maximum L minus A by L into A. This is ILD for bending moment. So, we have seen ILD for reaction at A, reaction at B, shear force and bending moment at any point C. Thank you.